Who has never had an upset stomach where you might end up vomiting? Not much fun, and it gives a horrible taste in your mouth. Or if you ever had what they call heartburn. Well, it feels like your heart's burning, but it's really acid getting up into your throat and your mouth, and it tastes awful, and acid is nasty. What is acid? Well, acid starts with water. This sort of looks like Mickey Mouse, but this is what a molecule of water looks like. You got a great big molecule or atom of oxygen and two smaller hydrogen ears, and they actually fit it in that angle on the water. Now, sometimes a chemical reaction will occur where it takes two of these Mickey Mouse atoms and molecules and separates one hydrogen from one head and puts it here, and this makes an ion that's positive, and this makes an ion that's negative. Well, when you get this concentration in the liquid, is an acid, and this concentration is a base. So here is a numbering system where scientists are able to tell an acid from a base. It turns out this has to do with the number of ions, logarithms, concentration. It's kind of complicated, but these are actually powers of 10, and so 7 is neutral. The drinking water you have is most likely very near 7. An 8 becomes a greater concentration of these ions, and it's 10 times more than a 7. A 9 is 100 times, add another 0, and out here you end up with 14, 7 more zeros. Now I'm going to demonstrate these things because purple cabbage has a material in it that's very sensitive to something being an acid or a base. This experiment you can do at home with parental help. And I've done a start on our product. I've got a little bit of cabbage in there. I'll turn it on, leave it on a few seconds, take it over here, and now what I'm going to do is take some of that purple cabbage juice and show that it's very sensitive to a chemical reaction, to whether it's an acid or a base. I'll start in this direction with Drano, and this is powerful stuff. So I pour a little bit of my indicator in here. I put some Drano down in there with a little bit of water, and it turns green. This is a slightly less potent base, ammonia. Notice it started out green and the chemical reaction continued. Now it's turning yellow. Blue. Baking soda. On our chart there it says it's a 10. Different color blue. We have the original cabbage juice here. Then we go to carbonated water, carbonic acid. Carbonated water sounds healthier than carbonic acid. Carbonic acid is just carbon dioxide that's dissolved in the water and turns to acid. So let's pour a little indicator in here and see what we got. Aha. Here we have vinegar, and vinegar won't kill you, but it's not much fun to drink. A little brighter red, and finally muriatic acid. So there we have it. Now what we can do is we can go along and use these indicator strips that are very sensitive to whether something's an acid or a base. And this is what you do with your fish tank or your swimming pool. You come along and you test see how potent it is. Wow, that's a potent one. That's as acid as it gets, apparently. Now we go to the next one. And this measures about, what do you think, 3 on the scale? And the next one is the Sprite. And a little weaker, about a 5. Let's go down this way. On the acid side, or the base side, here we have indicator strip. Wow. It's about, I've diluted it with a little bit of water. I would say it's about 12 or 13, about there. Here we have the ammonia, and the ammonia is about a 10. And here we have the baking soda. And it's about a powerful baking soda. It's about a 9.5. And so we've got one more strip here. We'll check our drinking water, which is just drinking water plus cabbage juice. And it's about a 7. Now actually the drinking water is a little bit different than 7. Sometimes it tastes a little better, but a very small difference. So I've now told you everything you need to know about pH. Tune in again for a Sunday science snack, and we'll have something else cool.